In an earlier video, we solved a problem in which the magnitude and direction of a vector were given, and we used that information to determine the components of the vector. In this example, we're going to go the other way. We are given the components of a vector, and we want to use those components to determine the magnitude and direction of the vector. Okay, so this is our vector A here. You can see that we have been given the x component of the vector, that is 7 centimeters. Also, we've been given the y component of the vector, that is 4 centimeters. And from that information, we want to find the angle between vector A and the plus x direction. And we also want to find the magnitude of the vector. Okay, so I'm going to proceed in a similar manner to the previous video. What I'm going to do is I'm going to come in and I'm going to draw a geometric right triangle whose hypotenuse coincides with the vector. Okay, so I hope you can see that I'm drawing a geometric triangle here in red. Okay, and now I'm going to just take that geometric triangle and I'm going to copy it off to the side. Okay, so this is a geometric triangle. It's supposed to be an exact copy of the one I drew over here. So this one would also have the angle theta in here. It would have a right angle here. The length of the hypotenuse for this triangle would just be the magnitude of vector A. The length of this leg over here would be the x component of vector A. So this matches this. And then the length of this vertical leg of the triangle would be the same as the y component of vector A, so that this matches this. Okay, so now we want to find the angle in here, and we might think about what trig function we'd like to use. Well, if we only have the opposite side of the triangle and the adjacent side of the triangle, you can think which trig function involves just the opposite side and the adjacent side. And you can check your notes if you don't remember. I'll give you a moment. Okay, and I hope you remembered that the tangent of the angle theta is equal to the length of the opposite side divided by the length of the adjacent side. Okay, the length of the opposite side is the same as the y component of the vector. The length of the adjacent side is the same as the x component of the vector. Okay, so to solve for tangent theta, you can just cover up that part in the middle there, and then take the inverse tangent of both sides of this. Taking the inverse tangent of tangent just gives me the angle theta. Over here, I have taken the inverse tangent of AY over AX. Okay, so I can substitute now so that I have the inverse tangent of 4 centimeters divided by 7 centimeters. Put this into your calculator. Remember to use degrees mode. This will give you 29.7 degrees. Now I'd like to find the magnitude of vector A. Now, at this point, now that we know both of those legs and the angle, there's a variety of ways to get the magnitude. But the most straightforward is that we get the magnitude. The most straightforward is we get the magnitude of the vector using the two components, a sub x and a sub y. Okay, and how do I make that connection? Well, notice that AX and AY are the legs of a right triangle. And now the magnitude of vector A, that matches the hypotenuse of the right triangle. So we can use the Pythagorean theorem, which says that the square of one leg, here AX squared, plus the square of the other leg, here AY squared, equals the hypotenuse squared. Okay, so from here, we can solve for the magnitude of the vector. So I have magnitude of vector A equals the square root of ax squared plus ay squared. Okay, so now I make my substitutions. Okay, so I have 7 centimeters, quantity squared, plus 4 centimeters, quantity squared, square root. Okay, so this gives me vector A equals, just put that all in your calculator. I get 8.06. And remember, we carry the unit. Notice that the unit of the stuff inside the square root here is centimeters squared. If you take the square root of centimeters squared, you get centimeters. Okay, so the magnitude of this vector here would be 8.06 centimeters.